This meeting is being recorded.
Okay, good morning, everyone. Just make sure that the connection is working. Could you please in chat area, just a couple of you say you can hear me? Good, thank you. Okay. On Monday, we started assembly modeling in SolidWorks, and if you remember, we just put this guy here. If you remember, we said in SolidWorks environment, we can use a mate in order to connect the parts together, and this is the same terminology that you had in Inventor, which is we called mate constraint. And today I'm going to talk about a little bit more about assembly, what you can do with assembly in SolidWorks. First of all, let's talk about how we can create the exploded state of an assembly. You know what is the exploded view, yeah? If you have an assembly and you want to show that how people can put the parts together in terms of orientation and position, you are going to create the exploded view. And for example, if you look at this slide here, for this assembly, this is what we have. And now, if somebody wants to put the parts together, needs some sort of guideline or some sort of help, the best way to show is to create the exploded view. And as you know from Inventor, exploded view, when you want to create the exploded view, you have to move the part in assembly environment. Now you have you put lots of time in this assembly. You applied mate to put the parts together, and the question is, for creating that exploded, are we going to kill the mates? Are we going to get rid of the mates in order to create the exploded view? Answer to that question is no. In exploded view, when you want to create the exploded view, what's happening here is you are going to create a configuration of that assembly, and the exploded view will be saved in configuration, but the mates will be there. It's just a view, as name said. And also you can create some line, this is called line sketch in SolidWorks assembly environment, to show the direction of assembly. For example, if you want to put these 4 screws here, you can create exploded view, and then you can add those sketch, line sketch. Let me go to SolidWorks and show you example. Let me open the assembly file. There you go. If you look at here, this is the assembly. I have this assembly. I put all the parts together using mate. If you remember from last time, oh, come on. All right. Now, if you remember from last time, this is the assembly design tree. You have nodes. Each node represents one part in graphics area in your assembly. And if you look at here, you have all the mates that you applied in order to put the parts together in appropriate position and orientation. Now, if you want to create the exploded view, if you look at the assembly command manager, here what we have different tools, and one of them is exploded view. If you just click on that one, you will end up with explode property manager, and here you can start creating the steps. Steps means here that you can manage, or you can sort the way that you are going to create the exploded view. For example, step 1, this is the default. Here what you have, I'm going to select the parts, for example, say this part and this part, I'm going to select those two parts. I want to move them down. And you're familiar with this triad. We talked about this triad on Monday. This is the way that we can move the part along or about three axes, X, Y, Z. In this particular situation, I want to move these two parts down. I'm going to drag Y axis, as you see, and then step one is created there. Then I'm going to say done. Then step one is finished. Then next, for example, I'm going to say I want to move those four screws, 1, 2, 3, 4, and I'm going to put those a little bit down here. This is a step 2. I can continue. I can say this time this one is done, then step 2 is done. See what's happening in Explode Property Manager. You have 2 steps. You can look at the steps details, what happened. You can modify those steps if you want. You can delete, you can even change the order of those steps. Let me continue this one. I'm going to create a step 3. I'm going to select these 3 parts and move them. Oops. Something happened, sorry. Now, let me just back to this exploded view. Something happened to it. When I'm sharing this one, the speed is, see, it's jumping. Okay, now one more time, let's go here. Exploded view, say step 1, 2. Yeah. Next step, I'm going to move this one and this one. Okay, let's accept. Now, this is the exhibit. You can continue. Yeah? As you see, it's a little bit art. It depends on you, and you have to spend time in order to create a neat exploded view, something that is clear in terms of the orientation and position, and also you can add, as I said, you can add explode line sketch to show the way that the people are going to put the parts together. I'm going to invoke that one. As you see, you're going to go to a sketch environment. You can use the tool that you have in the sketch environment. In this case, what I'm going to do, I'm going to say, just for example, I'm going to say, I want to put this part, say, all the way here. All right. Next, I'm going to say, I want to, oops, time. I want to put this part. Go to assembly one more time. Yeah. Yeah. Stay there. Wait, accept. And add more. Up here. Say there. And so on. You can continue. Then you are going to add more sketch line here to show the direction of the assembly here. See, you can put those kinds of sketch line helps people to see where they can put the component and what is the orientation of the component. Now, what I'm going to do here is I'm going to save, and now let's see what's happening here. You have them exploded view. However, the mates are there as well. We didn't touch the mates, yeah? We didn't touch, we didn't delete any mates. The mates are there, and assembly exploded view is generated. Now the question is, how can I back to my assembly? If you right click here in the graphics area, there is one item, it says collapse. You can select that one, and SolidWorks is going to show you the assembly instead of exploded view. Now, if you want to back to exploded view, that's a little bit tricky here. Just please pay attention. If you want to back to exploded view, in here, what we have a feature manager design tree, and the third item here is configuration manager. If you select that one, your exploded view was saved in this configuration manager. You can go there and you can double click on that one, and now you have the exploded view. The point here is, when you are in the command manager, when you are in design tree, what you see here, you don't see the exploded view. You can come here and say, okay, collapse, then you have assembly. But if you want to have access to exploded view, you should go to configuration, and here you can go to and select the exploded view. Now, you can create more than one exploded view, and each time you are going to say exploded view here in assembly environment, there will be another node here which says exploded view, for example, 2, exploded view 3. Then be careful when you're creating exploded view, and you want to create only one. If you want to just create one, then every time you go there, you have to open this one, and then from there you can go and edit the feature. If you want to add, if you want to modify, do not create more than one exploded view if that's not your design intent, if you just want to create one. And always pay attention to configuration manager. In configuration manager, the exploded view will be saved in configuration manager. You can access to that one, and you can modify, even you can modify the steps in exploded view. All right. This is what I want to say about exploded. Do we need exploded view in this course? Yes. When we go to FEA for assembly, you need to create exploded view from your assembly. Any question at this point? All right. Now, let's go back to PowerPoint. Okay. Now, one more thing that we are going to use that one in FEA when we later on, and it's very interesting tool in SolidWorks in terms of CAD. What is called interference check in an assembly. See, here is the point. When you are working as a mechanical designer, you're going to create the CAD file. You're creating the CAD files. You're going to create assembly and parts and drawing. And when you have the 3D model of parts and assembly, next step is what? To create the shop drawing. Yeah, you want to create the shop drawing. When you finish and you are 100% sure that the design is finalized, and you have that confidence that your design is okay in terms of function, in terms of CAD, in terms of tolerances, in terms of sizing, material, everything. If you're 100% sure, then that's the time that you want to create shop drawing. All right, because creating shop drawing takes lots of time. When you want to create the details, then you don't want to create the details and then make a decision later on and change the drawing. Then you will end up with lots of rework. Then you have to have some sort of tool to make sure that your design is okay in terms of interference between components. Typically, what people do, or what was a good practice, and it is still good practice, is they check the sizes, and sometimes they create a drawing and they use a different color of highlighter, and they highlight the dimensions. They start from one part and look at the connection between part, say one part A. They look at the connection between part A with part B with part C, and they start checking the drawing. For example, one dimension in part A is somewhat common with the dimension in part B. They start, for example, they use yellow, means that there is some concern. Red is screw up, there are some problem, and green is okay. And when you have the shop drawing, that's one way to do interference check. And the job checker, it was a title for years in industry. And the person is going to check the drawing is senior person, was senior person, lots of experience, and it's from experience and also even salary hierarchy, the checker is higher than the designer. But it was a job, and it is lots of companies, they do the same approach. But here's what we have in CAD. Let's see how we can use CAD to help us to make sure that there is no interference between the component. Because when you are designing a simple project, like when you have 4 or 5 parts, it's obvious you can check those stuff. But what about you are designing a machine, and machine has 100 parts? What you want to do? There is no way that you can look at the design, say, okay, everything is okay, and save, I didn't screw up in terms of interference between the component. Because there are lots of mates, and there are lots of parts, and most probably, if you want to apply in some area, you want to have interference in some area. The interference between the component is not your design intent. In some area you have interference and you want it, but in some area interference is just a mistake. Now, in SolidWorks, having said that, in SolidWorks, what we have checking interference in an assembly. That's a check interference or interference check is a tool that we have in SolidWorks in order to find the interference between the component. If there is one, I don't know, message we want to take from my lecture today is how to use this tool. That's a very powerful tool when it goes to the CAD and design. We'll talk about how we can use that one in FEA, but the power of this tool is when you are going to design and you want to have confidence in your design, which is very important step in your design, because you want to create a shop drawing, and at the same time you want to make sure that there is no interference, or if there is an interference, this is your design and you want it. And also we have another tool which is called collision detection. Collision detection means that if you look at here, for example, if you assume that you're designing a machine and this part is moving along the x-axis in this direction, yeah, and for some reason you forgot to delete this feature in your design, or for some reason you made a mistake and left this feature in your design. Definitely, if you manufacture those components and put them together, you cannot catch those kinds of error until you finish the project in terms of manufacturing. When you assemble the part, physical part in the shop floor, then that's the time that you can see, oh, I made a mistake here. And now that rework is very expensive, very time consuming, because you have to repair, disassemble everything, put the parts, put it in the milling machine, and get rid of those features. But in the CAD environment, you know that if you want to get rid of this feature, it's a matter of just a couple of clicks. But in the shop floor, it's a time-consuming, very expensive process. Maybe it takes a couple of hours or a couple of days to get rid of those kinds of problems, and then reassemble everything. In order to avoid or in order to check those kinds of problems when you have moving component, what we have in SolidWorks, we have collision detection tool, and you can move the part as you see here, and when there is a collision, the parts both parts will be highlighted. Then you can see there is a collision between this component. Then now you can make a decision: is it what you want, or is the design flaw, is the mistake? And you can work on that. What I'm going to do is I'm going to show you one example from collision detection and interference check. This example, you are going to do that one in the lab. It's part of the lab that we are going to do this week. Then let me go to SolidWorks. But before that, before going to SolidWorks, any question about interference check and collision detection, what they are and what is the problem before using the tool? All right, it seems that there is no question. Let me go to SolidWorks. This time I don't need this one. Don't save. File open. Desktop. Where was that? There you go. Okay. As you see here, we have a desk lamp, and assume that you are designing this desk lamp, and you want to make sure that there is no collision between these components. You want to make sure that there is no collision between these components, and you are safe and sound in terms of your design, in terms of interference between the components. Now, as you see, if you make a mistake, it's very, even for this simple part, is you have to zoom in, look at this corner, you have to look at this area, look at this area, and you don't see anything, yeah? If you go here, you have to look at this area, it seems that everything is okay, yeah? Then with naked eye, this is what you see. Seems that the design is okay. And now what's happening? Next step is you're going to create a shop drawing. When you finish that one, you apply all the mates, you put the parts together, it seems that everything is okay. But let's check this one with using the interference check. I'm going to go to evaluate, and here there is a tool, see, interference detection. I'm going to invoke this tool, and now it says what you want to do. Interference detection property manager, it says select a component. In this case, since I'm just dealing with 4 or 5 components, I said let's do interference detection for whole assembly, but you can select a component if you want. And I'm going to say calculate. It's going to calculate, and here will be a result. And what's happening here is in this table, it says that there is an interference between 2 components, this component and this component. All right, we didn't see that with naked eye. We just zoomed, even I zoomed in to all the area that all the connection between the component. I didn't see anything. But let's see what's happening here. It says that there is interference. I'm going to say where is the interference between these 2 components. And if you look at here, that red area, that's a design flaw. This is the problem that we have now. There is interference here. I'm not sure that number is useful or not, but it's going to give you the volume of that interference, and it's going to give you the part that have problem. Now, if you are designing a machine, you may end up with, say here, you may end up with, I don't know, 10 interference, and you're going to look at each of those, and some of them maybe your design intent is exactly what have interference between the components. Sometimes, and most probably for most of the time, what you have is those are design flaws, those are mistakes. All right, this is what we have. And one thing that we have here is, I'd like to talk about that one a bit, is it says treat coincident as interference. What does it mean? It means that if there is a coincidence between 2 parts, then there is no interference. There is just they are touching each other. Okay, but this is not interference. There is no gap between the component, but at the same time there is no interference. Now, sometimes for some reason, and we have that one in FEA, you want to find the area that two parts are touching each other and there's the interference. Okay, you can go here and select that one and again back and say calculate. This time it's going to give you the area that you have, which is parts are used coincident made in order to assemble the parts. Now, for example, this area, it's between these two parts, this part and that part, and between these two, what you have touching area. You have a common area that two parts are touching each other. What is application of that one? We'll talk about it when we later on. We'll talk about FEA in assembly. That's it in terms of interference check. And then what we have collision detection. Let's see what is a collision detection. I'm going to go to move. Again, you are going to practice this collision detection and interference check during the lab session this week. But just I want to demonstrate, make sure that everybody knows what is the concept, what is the application. But how to do that, you're going to practice, don't worry about that. I'm going to go to assembly, and here I'm going to go to move component. And now what's happening here is you are in the move component, and there is one item here. It says collision detection. Okay, there is a standard drag and there is a collision detection. I'm going to select that one. And now what's happening here is if I move the component, if there is a collision within the component, you can create a sound, or you can highlight the faces that are colliding. In this case, I leave the option as you see. I'm going to move the component. See, when I move the component, it says the model started in a colliding position. We know that. Remember, these two parts, we had interference. They were colliding. In the beginning of when I drag the part, that message is obvious. I'm going to say, yes, I know that, but I want to continue. I'm going to drag that one and see. Just this is the example. See what's happening between these two parts. See? Or these two parts. Let me zoom in a bit. It means that now these two parts are colliding. Okay, continue. These three parts are colliding. And this is a simple example to see how you can use the tool and what is the tool. But if you in the real life, when you're designing a machine, you have hydraulic cylinder, the parts are moving, and you want to make sure that you are safe in terms of collision. Collision detection is different from interference check. Collision detection is that when you have motion, when you have relative motion between the component, you don't want to have crash between the component, you don't want to have collision between the component. All right. Any question about collision detection and interference check? All right, let me continue. I'm going to share my PowerPoint one more time. Now, in terms of assembly, there are lots of interesting tools in assembly, and I'll try my best to give you the most important tools that we have in assembly environment in terms of engineering analysis. Okay. First of all, we talked about that one, clearance, interference checking. We have mass properties. That's another interesting tool that we have in SolidWorks. You can look at the total weight, center of gravity, and mass moment of inertia that we are going to cover next week. But that tool is very interesting in SolidWorks. I'm going to show you later on. But those are same as I think you had in Inventor. But in SolidWorks, we have a very nice format in terms of how you can access to those mechanical properties in SolidWorks. I think it's talked about those. Let's go to SolidWorks and talk about mass property. I think that's time. Let's just share the screen. SolidWorks. All right. For this one, but let me just show you one point here. Let's go to new part. Okay, I'm back to this assembly. I'm going to show you something else. Okay, let's create a part, yeah, together. I'm going to create a simple part, say block. And I'm going to apply a feature. Please pay attention to what's happening here. What I did, I just created a part. There you go. Simple block, yeah. Done. I created this part, a simple block, and now I'm going to go to evaluate one more time. And here is, where is that? This is mass property. There you go. This is mass properties. And I'm going to look at the mass property of this part. There are lots of information here. We'll talk about them next week. But one thing that I want to talk right now is, what is the weight of this part? It says how much? 1726.35 grams. Says the weight of this part is 1726 grams. All right, let's see what's happening here. This is the part. And what it says in terms of material here? Material says not specified. Okay, material not specified. When I look at the mass property, it says that the volume, the mass is 1.7 kilogram. Now the question is, how come? You didn't say what is the material, but you have the mass property. Can you see the contradiction? Because we didn't say what's 1,000. Did you see the problem? But the issue was, we created the part. I went to mass properties and I realized that, okay, there is mass, 1.7 kilogram mass for this part, but we didn't specify the material. Anybody knows what's going on here? Is there a default material? Yes, but Carl, do you know what is that default material? The density was 0. No, it wasn't. Anybody knows what was the default value? Default material, sorry. Okay, Leslie, I'm going to check it. We can look at it together. But does anybody know what is the default value? Okay. The reason I'm asking is that is something that lots of people making mistakes. They pay attention to the detail and they end up with some sort of weird number. One application of mass property is what? We are mechanical designers, we design the machine, and by the end of the day, we need to know the weight of the machine. And what's going to happen, because we want to use crane and you want to move the part. There are so many issues related to the weight, yeah? And you need to know the weight of the machine or your product, and this is part of the design specification. And if you don't assign the material, it seems that something is going on in SolidWorks. SolidWorks is going to give you some numbers. Now let's go back to SolidWorks and share the SolidWorks. Okay, I see why you are saying 0. This is because I have 2 decimal places. Well, you're right, it's 0, but it's not 0. Let me go here. And see, can you see that mass properties, material properties, it says 0.001. It's not 0. The reason you have to see 0 here is it is 2 decimal places. If you expand that one, you can see if you go to 3 decimal places, it's going to be 001. Now, back to the point here. Interestingly, the SolidWorks is going to assume that this part made of ice. It's funny, even if it's made of water. It's funny, it doesn't make sense to have water this shape, or the best scenario is you can assume it's ice. This is the default material. Water is the default material. Be careful. Then if you are designing a machine and you forgot to assign the material, and let's look at the worst case scenario. The SolidWorks is going to assume that your machine made of water. That from CAD perspective, nothing is wrong because you're dealing with geometry. But when it goes to mechanical properties, then there is a huge difference between the density of water and density of steel. And you make lots of mistakes here. Why, you may say, why SolidWorks is going to SolidWorks considers water as a default? Because the density is 1. That's why. Because if you look at here, volume equals to mass. Anyhow, that is one point that you need to know about mass properties. Other than that, if you go to mass properties, okay, mass properties. See, there are lots of information here in terms of mass property. We talked about mass, volume, but next week I'm going to talk about the rest of the information that you have here. We need those information in this course. This is engineering analysis course, and lots of information here that was meaningless for those who are working with CAD. It's very important for those who want to do engineering analysis. But let's talk about this table next week. All right, let's see. All right. Now, next is 3D Content Central. Let's see what's happening here. In SolidWorks, there is a server that you can access to the CAD model of the component. As you know, there are lots of off-the-shelf components that you are going to buy, you are going to purchase, you are going to order from outside, you are going to outsource it. For example, if you are designing a machine and you need to have, say, hydraulic cylinder, you're not going to, most probably you're not going to manufacture a hydraulic cylinder. You're going to buy it from a company, or pneumatic cylinder, or DC motor, AC motor, or bearing, or gears, and so on. There are lots of off-the-shelf components that you need to use in your design. And those are not, you are not going to create a shop drawing for those. And all you are going to do is just put it in the bill of materials. And you're going to order those from company X or Y. Then there should be same concept in 3D modeling. In 3D modeling, we should have off-the-shelf component CAD model that you can import to your CAD model and use them in your CAD model. What I'm trying to say here is, in a same as the real life, that you can buy off-the-shelf component, and you are not going to manufacture them, you are not going to design them. All you need is some general specification, some information how to use them in your design, like as I said, like a motor, like a gear, or like a bearing, chain, and so on. Those are off-the-shelf components. In real life, you are going to purchase them, but you need to use them in CAD model in your assembly environment, because there are lots of connection with other components. You have concern about this, about the space, and so on. To solve this kinds of problem in SolidWorks, we have 3D Content Central for those components which are off-the-shelf components, but they are not a standard. Then we have two types of off-the-shelf components. We have a standard off-the-shelf component like bolt, screw, gears. Those are a standard. Doesn't matter who's going to manufacture. There are some standard, and all you need to do is you need to just get the CAD model. For those standard off-the-shelf components, we have toolbox that I'm going to show you. For those components, off-the-shelf components, which are not a standard, and you have to purchase them from a company, we have 3D Content Central. By the end of the day, here is the point. If you are going to create an assembly and you are going to use off-the-shelf component, you are not allowed, you are not supposed to spend your time to create the CAD model of those components. It should be ready somewhere. If they are a standard, like ANSI, and DIN, and those kinds of, if they are not off-the-shelf component, you need to go to the website of that company and find the part. This is very tedious process. Instead, this is called 3D Content Central, and you are going to download those files from that 3D Content Central. Let me back to SolidWorks and show you what's going on and what I'm talking about. This is the assembly that I had. If you look at here and go to design library, one item here is toolbox. Is it clear? Or see here, or you can find this one from go to option, go to add-ins, and here there is a toolbox. SolidWorks toolbox, there you go. But easier, it's easy to go here and find it. Now, what's happening here is that, okay, there's one question, I think. Two questions. Okay. Okay, it seems that some people are not muting themselves, and there's a complaint here. Could you please mute your speaker? I leave it up to you, because if you want to ask question, but if you don't do that, I'm going to mute it from myself. I don't want to do that really. The reason I'm not going to mute everybody is to just make sure that if you have any question, you can talk. But please mute your speaker. It creates lots of noise for other students. Thank you. Now, if you look at here, it says add in now. Here, if I double click on that one, it's going to add lots of information to SolidWorks. There you have, for example, ANSI inch, ANSI metric. Those are the toolbox that I said. Let's go to ANSI metric or ANSI inch. And here what you have bearing, you have bolts, keys, nuts, pins, and so on. Let's go, for example, to bolt. I can go, there are different types of bolt here. And if I go, for example, say machine screw, and a machine screw, I'm going to select this one and bring it to my assembly. See, here is, say, let's go to quarter. All right, and the length is, let's go to 2 inches, big one. And I want to show it simplified. I want to show it cosmetic. See, what's happening here is, now you have this bolt, machine bolt. You can import it from here and put it in your assembly and use it. We don't have this one in this course. You don't have to worry about this toolbox and also 3D Content Central, but it's good to know, especially next term you are going to do project and you need it. And now that item has been added to my design tree as well. Then let me summarize what I said here. You have toolbox in SolidWorks. It's not added in the beginning. You need to go double click here and add, because you don't want to upload all those information if you don't need them. And here what you have, if you go to one of those standards, you have different types of standard here. As you see, we have British, we have Japanese, you have German, and so on. You have lots of information here. There's lots of standard here. If you select one of those standards, you have lots of ready-to-use component or off-the-shelf component. For example, if you can go and select different types of bearing, you can look at the different types of keys, nuts, O-rings, and so on. Then you can bring those to your CAD model. However, those are for what? Those are for off-the-shelf component. It's for those off-the-shelf components, which they are standard. What about if I want to bring a part into my assembly, which is not a standard? If you look at here, oops. There was here part of that one. They moved it somewhere. Change that one. Okay, yeah, let me just, it seems that they changed that one. Let me just show you. Okay, let me just, I have to go, it goes to outside of SolidWorks. I have to share here. There you go. See, when you go to 3D Content Central, it seems that they changed that one this year. And okay, I have to update my slide. See, they call it now Marketplace. All right, they say Marketplace. It was, the name was in 2019 version of SolidWorks was 3D Content Central. It seems that they changed it to what is called Marketplace, 3D Experience Marketplace. Anyhow, if you click on the one that I showed you, I'm going to show you again, you will end up, but same concept. What you have a 3D model of the parts here, and you can go by category. For example, here you can say, you know what, I want to have electric drive, and here if you select that one, there are different companies. They are providing servo motor, for example. There you go. And in servo motor, you can select any of those. That you have pneumatic, you can select different types of pneumatic, different companies. Then what's happening here, you have catalog. It's like a same as a real catalog, yeah? And in this catalog, you have different companies. For example, I want to buy something from, what is that? Advantic. Let's see who is the guy. And here you can go to the company. If you want to purchase a part from a company, you know the name of company, you can come here and select the part. Or sometimes you don't know the company, you want to shop around and you want to say, okay, you know what, I don't know what company, what I want to buy is, I don't know, I want to buy, I want to get a robot. And here, if you go to robot, then you have 50 companies here, you can go there, and they have different types of robot here, and you can import the CAD model of that robot in your assembly. Then let me back to SolidWorks, and one more time show you what happened. If I go to SolidWorks, see, if you go here to design, SolidWorks resources, one item here is 3D Experience. They don't call it 3D Content Central. It was the name 3D Content Central. They changed that one. It seems that 3D Experience Marketplace, but same concept. Click on that one. You are going to go to the server. That server belongs to SolidWorks, and you can download the CAD files from there. Very interesting environment that you have in SolidWorks. Could you go over the assignment one more time? No, I don't have time to go through assignment. We have 2 minutes left. We're almost done. But what is the question, Mohammed? Is it something that you need help? Please send me an email regarding the assignment. One student asking about, is it possible to go through the homework assignment? I said there is no way. We don't have time. But you can contact me, send me an email, and we'll talk about it. All right, let me see. I think we are done, but let's just go and see what else I have in my PowerPoint. Yeah, that's it. And this is what we have during the lab session this week. We have this slider crank mechanism. We are going to put the parts together and create assembly. This is something that we are going to demonstrate during the lab session. All right, any specific question related to material that we covered? All right, then have a good day and see you 2 sets at least during the lab session. Bye.
The recording has stopped.